Right, so I was asked to do page 236, question 3. So it looks like this is a big rectangle, and we take a triangle there, and we take another triangle there, and we're told that that distance is 6, that distance is 3, that's 5 high, and the distance from there to there is 7. Okay, hence find the area of the shaded portions of the diagram on the right. Okay, so the way to tackle this, guys, is to think about that the area of this part here, that's the area of a triangle, and that's the area of a triangle there. So we're going to use a half base by perpendicular height. Now, let's deal with this one over here first of all. So the base for that one, well, the base is going to be 5. So it's 5 will be the base, and its perpendicular height will be 6. So it's going to be a half times 5 times 6, which is equal to 15. So let's call that zone 1. Let's call this place here zone 2. Let's call this place in here zone 3. So zone 1 we can get by finding the base is 5 because it's a rectangle, and then it's quite simply the half the base by the perpendicular height. So let's call that AZ1. So the area of Z1 is equal to 15. Let's try and work out the area of Z2. So zone 2 here. Well, again, it's a triangle, so we want to use the formula half the base by the perpendicular height. Now, we know the perpendicular height this time is going to be 5, so it's 5 high. But the base, we have to do a bit of thinking about this. So it's 6 and 3 on top. So therefore the entire top must be 9. And if it's 7 from here to here, what does that mean we're going to stick in there? So if it's 9 from here to here, and if it's 7 from here to here, what's left that we have to put in there? Yeah, it must be 2, right? So therefore we have a 2 as the base of the zone 2 triangle, and that gives us 5. Find the area of the shaded portions of the diagram, hence find the area of the unshaded part. Now, we have to start thinking a little bit kind of imaginatively here. So, I have the area, let's see if I have a green pen. So I have this area here, that's the area of a rectangle. And then from that, I remove the red areas. So from that I subtract these areas here. And when I subtract those areas from the big green area, I'll be left with the space in the middle, our zone 3. So let's maybe call it Z1, area Z1 plus area Z2 plus area Z3. So that's what they must all add up to, right? Yeah, so if we add up all of the areas in the rectangle, it should equal whatever it's going to equal. Now, we know that the area in the rectangle, well, it's 9 wide, because it's 7 and 2 or 6 and 3, so it's 9 wide and it's 5 high. So to get the total area, I simply go 9 times 5, which is 45. And now, from this, I can subtract. So this is the 3 areas, is 45. But I only want Z3. So I'm going to go 45 minus area zone 1 which is 15. And I'm also going to subtract the area of zone 2, which is 5. So this is here, and this is here. Let's push that up a little bit. So what does that mean? That means area of Z5 is equal to 25. Sorry, zone 3. So the area of zone 3 is 25. So it was one of the questions you had for last night. A very nice question, particularly because it's getting you to start thinking about removing areas from bigger space. Okay, it's a really nice way of thinking about things. So I'm now going to have a go at, I'm going to push it forward a little bit, and I'm going to have a go at question 11. So this is question 11, page 238. For those of you with the old book, for those of you with the new book, I'll put up the corresponding page on Microsoft Teams. And I'm going to do parts 2 and 3. Calculate the area of each of these trapeziums. Right, so a trapezium is it's a shape that has 2 parallel sides. So it's like half of a parallelogram. So this side here is parallel to this side here. Do they have to be at right angles? I'm not sure if they have to be at right angles or not. I don't think they do. Yeah, I think we're okay with just the opposite sides, one pair of opposite sides being equal. Sorry, one pair of parallel sides being, sorry, one pair of sides being parallel. I think that's the requirement for a trapezium. Yeah, when I was in primary school, my teacher told me we can imagine it being a triangle with the top chopped off. And the top is being chopped off parallel to the base. Okay, calculate the area of each of these trapeziums. So, when we're faced with this type of question, I break it down to shapes that I know how to find the area of. So I don't know how to find the area of a trapezium. So what I do is, I break it into a triangle and a rectangle. I know that this is 8 in total here. So it's 8 in total there. So therefore from there to there must be 5, because it's 5 over here. Therefore from there to there must be 3. We're told it's 10 wide, okay? So to find the total area, I go area, again, I like that zone 1 and zone 2, so let's call that zone 1, let's call that zone 2. So area zone 1 is equal to 10 by 5, which is equal to 50, easy peasy. And then area zone 2 is equal to, well, that's a triangle, so it's going to be a half the base by the perpendicular height. The base is going to be 3, and the perpendicular height is 10. Now, I'm just calling that the base. I could just as easily call that the base, yeah? I could go a half times 10 by 3. But because multiplication is, what word describes multiplication again? And we can change the order. It begins with C, the C word, yeah? So it's 15. So that word back there is commutative, okay? So it's commutative. So because this is commutative, a half times 10 by 3 will also give me 15. So that's the strategy that we use. And we break the given shape into shapes that we're able to find the area of. I'm running a bit low on paper, so I don't want to just rip this out. Do you know what? I probably will. Okay. Is there enough space in there? So this is part 3. And looks very messy, sorry. This is going to be part 3, and we have a trapezium that looks like this time. That's 24, that's 18, and that's 22. Now, that's a right angle, that's a right angle. So again, well, the only way I can do this is break it into shapes that I know how to get the area of. So I put a line across there, and I know that this area in here, let's call it zone 1 and zone 2. So zone 1 is equal to area zone 1 is equal to 22 by 18. And the area of zone 2 is equal to well, it's going to be a triangle, so it's going to be a half the base by the perpendicular height again. And our base this time, well, if it's 22 from there to there, it must be only 2 from there to there. So it's a half of 2 times 18, because its perpendicular height is obviously 18 over here. So that gives me 18. And 22 by 18, gosh, that's a calculator job. That's equal to 396. So total area is equal to 396 plus 18, which is equal to 414. So that's how I would do part 3. And I actually forgot to find the total area for the part 2. So total area equals 50 plus 15, which is equal to 5, 0, 6. So it's 65 is the total area of, I'm going to put an implication there rather than equals. So it's 65 is the total area of the trapezium 2, and trapezium 3, the total area is 414. So any questions on that? Let me know. Tonight for homework, I'm going to give you question 8, 9, and 10. Yeah. 8, 9, and 10 for homework tonight, okay? So good luck with that, guys, and I'll check in with you again tomorrow.